Welcome back, guys. Our new topic is Centroid. At the end of this video, you should know how to find the centroid for a composite material. In this case, this composite material has two parts. This is broken down into two sections: section A and section B, as we have seen here. Um, the principle for finding the centroid are pretty much simple or somewhat similar in some cases to the previous method. So to find a centroid for this one, I'm going to draw a diagonal from here to here, one from here to there, as this is rectangular. So this is relatively easy to locate a centroid. Let's try to make this a little bit straighter. So at the point where both of them meet is the centroid for this part A, centroid here. In like manner, I will be drawing a diagonal line from here down to here. Well, let me just use sketch. And here is my, let's call this C1, centroid 1, and this centroid 2. So we have centroid 1 and centroid 2. Now that we have determined the centroid for both pieces of material, it is now up to, well, this material is assumed to have the same thickness, same type of material, and same consistency in properties. The next step is to establish a ratio between both areas, between area A and area B. Now, area 1 has an area of 60, area A has an area of 60 by 20, which gives 120, while area B has a area of 80 minus 20. 100 minus 20 is 80 by 20, which is 80 by 20, which works out to 1600. To break this ratio down into smaller portion, we cancel here, cancel there. That gives us 12 over 16. We then divide both areas by 3. This into 4. We divide both areas by 4. This into 4. 4. We end up with 3. 4 to 16, we end up with 4. So the ratio works out to be 3 to 4. Now, the next step is to join between both centroids. So we join from here to here, which we did here, and establish and divide the space into the ratio which works out to be 7. So the next step is add 4 plus 3 gives us 7. The rule states that the centroid is located, in a case we have a ratio, the centroid is located closer, or the smaller portion should be marked off closer to the larger body or larger area. In this case, B is 16, area is 16 millimeters square, here is 12 millimeters square. So we divide this into 7, and we just from here we mark off 1, 2, 3, which is the smaller ratio, and then we have 1, 2, 3, 4, which is the larger ratio. The centroid is then located at this point, at the part 3. So the centroid for this body is located here. Our next step is to determine the distance the centroid is from our datum line, or from our XY line. So if here is 0, the centroid is located this distance, and the Y value, this distance here, from here to here, which is the Y value, and from here to here, here to here, is the X value. So the centroid is located this distance on the X, and that distance on the Y axis, or the Y bar. And that is basically how we find the centroid for a composite material.